Mercury, secrets of the closest planet to the Sun. Fascinating and being the closest planet to the Sun, Mercury is a world of incredible conditions where the boundaries of space are pushed. On its sun-facing sides, temperatures rise up to 430 degrees Celsius, which is hot enough to melt metal. However, when night falls, the temperature drops to minus 173 degrees Celsius, cold enough to freeze even steel. This difference of approximately 600 degrees Celsius is a direct result of Mercury having almost no atmosphere. Since there is no atmosphere to absorb the heat, the thermal energy received from the Sun must immediately radiate back into space at night. How can there be ice on Mercury? Despite these extreme high temperatures, water ice exists on Mercury. Radar observations and research from the Arecibo Observatory detected ice in craters at the planet's poles that remain in eternal darkness. These craters never see the Sun, while their surroundings are scorching hot, their interiors remain frozen for billions of years. Space observers and researchers believe that comets crashing into Mercury in the past may have carried this water. This discovery is not just about ice structures and craters. If a planet like Mercury can preserve water, it reopens questions about water and even the possibility of life in our galaxy and across space. Is it hard to go to Mercury? The Bepi-Colombo mission is an international endeavor launched to study Mercury, the planet closest to the Sun. Trying to reach Mercury is, in fact, like trying to fight against the Sun. The Sun's massive gravitational pull constantly accelerates spacecraft. If the craft is not slowed down, it will fail to reach Mercury and fall directly into the Sun and burn. For this reason, the Bepi-Colombo mission cannot follow a direct path like a typical spacecraft. The spacecraft follows a very long and complex route of 5 billion kilometers, making 9 planetary flybys, including Earth and Venus, and orbiting the Sun 18 times. This route and complexity are for the purpose of slowing down. Bepi-Colombo also uses very special ion engines. These engines, which operate with continuous but very low thrust, prevent the craft from falling into the Sun. War against the Sun, protection. Radiation from the Sun in Mercury's orbit is 10 times higher than on Earth, and this radiation is powerful enough to damage technical devices and circuits. Therefore, Bepi-Colombo is surrounded by ceramic heat shields. This protection system shields the devices from extreme radiation and heat, ensuring they remain active throughout the mission. A giant metal core. One of Mercury's darkest, misty mysteries is its internal structure. 85% of the planet's radius consists of a metal core. This makes Mercury the densest and hardest planet after Earth. Why it possesses such a massive metal core remains a dark enigma. According to one theory, billions of years ago, in the early solar system, Mercury experienced an incredible collision, and its rocky mantle was scattered into space. Another theory suggests that the radiation from the young Sun stripped the light materials away from the planet. A shrinking planet. Mercury is constantly shrinking. The giant fissures, craters, and ridges seen on the surface show that the planet has shrunk by nearly 14 kilometers throughout its history. This proves that the metal core is still cooling and contracting. In other words, Mercury is not a dead planet as once thought. A volcanic history. Bepi-Colombo data showed that Mercury once had intense volcanic activity. The Caloris Basin is thought to be not just an impact crater, but a giant fossilized sea of lava. The star-shaped fracture at its center, called Pantheon Fossae, is a trace of lava movements rising from within the planet. Furthermore, some volcanic eruptions were caused by the explosion of volatile substances rather than impacts. The existence of such substances on a planet like Mercury is a chemical mystery in itself. Salt glaciers and hidden chemistry. In some craters at the North Pole, scientists discovered salt-like glaciers. These structures may contain not only salt but also other volatile, explosive, and valuable compounds. These regions, protected from the sun, suggest that even if Mercury's surface is like hell, the underground could be very different, bringing topics like space mining to the agenda for Mercury. Weak but strange magnetic field. Mercury has a magnetic field, but it is only 1% of Earth's, and this magnetic field is significantly offset from the planet's center, a condition not seen on any other planet, making Mercury unique. Scientists believe that the tidal forces created by Mercury's orbit keep this field alive by moving the core elliptically. A metal tail. Mercury has no atmosphere, but it has a very thin exosphere layer. Sunlight knocks sodium atoms off the surface, creating a star army of metal stretching for millions of kilometers behind it. This effectively turns Mercury into a metallic comet. Conclusion. To call Mercury a silent and dead piece of rock is an insult. With its extreme temperatures, giant metal core, volcanic past, magnetic field, and metal tail, it is a massive laboratory trying to push the limits of physics. BepiColombo and future missions may reveal answers about Mercury's past and even how the solar system was formed. Mercury and the Sun are slowly changing. And this change reminds us that even in the harshest conditions of the universe, movement never stops.